This video is part of the Research Mentoring Initiative. The Mentoring Initiative will try and give you insight into research, exploration, dissemination, and how to structure the way you might do research, how you might align reading relevant articles and structure that into diagrammatic depictions. The first thing we're going to think about is this idea of a research relevance item. Throughout this video, we're going to look at research relevance tables, research relevance diagrams, research relevance trees. Any type of depiction mechanism is very important for understanding and disseminating your research. Well, let's start with this page then. This page depicts a research relevance table. Why is that terminology of that triple important? Well, research could be delineated, could be written up in paragraphs, in chapters, but really a faster way to visualize for the first time reader, compare and contrast different types of research is via a diagram. So this video puts forward the premise that research relevance and research relevance diagrams are part of the issues that one should cover if one is looking at research. So let's start with this diagram. This diagram breaks down some of the areas of reuse of information and the reuse research into a number of subcategories. The first one is combining information, the other is knowledge reuse, and each one under their categories has subcategories that break down this major headings, these two here, into subheadings. And they align to a number of papers that cover these areas. And as you can see, some of the areas, the sub-classification areas, only have a few papers, whereas others, which maybe have a larger amount of research or the preparation of this table and the reader of this background material found more information in this area. So let's move on then. We've looked at one research relevance table. Let's look at another. This one's slightly different. This was done by a very good PhD student, and he compared and contrasted certain columns. Now this is to do with the idea of symmetries in weights in evolutionary neural networks. So in fact it's concentrating to be more specific on permutations of weights. Now when the student looked at this, he found that there was actually no explicit terminology to explain this conundrum of, well, what's it called? Well, in some papers it's called explicit permutations. In others it's called equivalent roles, and some they don't even specify it. So what does this research relevance table tell us? Well, the good news about this is it's a very detailed research relevance table. First thing is it has a caption which is explicit. Now this should be your norm. A very explicit caption that enables you to understand the table, any table in fact, not just a research relevance table, and not read the surrounding paragraphs of text. Also, it's got subnotes to help the reader understand the sub-issues in here. So how has he used this research relevance table? Well, he's put the references here on the left hand side, and then he's mentioned the issues here. So let's go and look at this in another diagram. So here's another diagram, and here Stefan's actually got more columns. So it's become a bit more of a issue. We've got permutation problem, competing convention, structure, stroke, functional mapping. And now he's done something quite good in the sense that he's highlighted a very important issue, which is the severity of this issue. So here we see that this issue that they're all talking about, which they can't agree on the naming convention, are compared in different papers, and the severity of it in the papers is also mentioned. And again, it's a good diagram because it's got a fully annotated and described caption and subnotes as well. Excellent research relevance table. Now let's look at another research relevance. This is a research relevance diagram. So in this case, what we're looking at here is a research relevance tree. So again, shows you the interactions between items in the research. Now we're going to look at another diagram. Again, it's structured slightly different. Now don't think that this wasn't put together especially to get these type of alignments. And in fact, these entities here may have been placed here specifically to get these type of diagrams of rows of histograms, if you like, normally put in the Y plane are actually put in the X plane here. Now the nice thing about this research relevance diagram, table in fact, is that they have the references here, maybe the types of networks here, and the different types of behavior from the realistic neurons to the structure that they're talking about in these papers along the Y-X axis. So that's another research relevance table. Very good. Let's move on to another. Now this one does something slightly different. This puts the references inside the diagram. So it's an XY plot, single two-dimensional plot. It has the size of neural network and their biological plausibility. So a very good diagram. Not very large caption, so you might have to read a little bit more about that, but a good research relevance graph. Now this was done by my PhD student, Hassan, and he's done a very good job of depicting, let's minimize it a bit to try and get the whole diagram on one page. This is a research relevance tree. Now the nice thing about research relevance trees is you can break down a sub-issue, in this case hybrids, into a set of subdivisions and stratify them into, if you like, sub-areas in those areas. So you can see here that you might think hybrids, well, it's just one issue, isn't it? But no, there's lots of sub-issues in it. Anything from controlling the hybrids, because a hybrid is a number of items working together, or the order of execution of the hybrids. Are they sequential, one after the other, or are they parallel? Or the level of hybridization. And then an explanation of what they are. So this diagram is a research relevance tree. Now this diagram that I'm going to show you shows two depictions of the diagrammatic and behind that the databases, which is really relevant for research. Let's go and see these two diagrams then. Now this diagram really utilizes a methodology for building up your research in a database. It's actually called HistSite. This initial idea and the concept was undertaken and developed by a PhD student and is now under a publisher's rights, and they control it. But what does it do? Let's have a look at what HistSite does. Well, HistSite will let you build up a database of information of your research, and then the real thing that I want to show you is what you can draw once you've built up these, and this is it. This is a research relevance temporal diagram. So what have I just said? I've said with this HistSite you can develop a methodology of depicting the references you've read and correlated and, if you like, mapped in your background research, and see which ones are the most relevant. So here we've got a temporal timeline from 1967 to 2000, and we can see one of the most relevant papers here is this one in 1998, and maybe a founding paper is this one. So this depiction enables us through the research relevance temporal diagram to understand how the references are associated. Now let's look at this is so maybe important to one company that they've even put it on their website. So they've got his site, the trademark, and they've developed this diagram to show you how their research has linked and even the timeline. So that's very relevant to show you a diagram that's a research relevance temporal diagram. Now these are a bit of a diversification. This is just a very simple table to show you about the work you're undertaking and maybe the influence. So I'm not going to say too much about that. There's also a framework where you can highlight what this is, so it expands the table if you like. And again, here's another table, again looking at the work and again looking at the questions that you might ask. Now this research relevance table was again done by Hassan, and I think it's a very good research relevance table. So I explain why it's a good research relevance table. Well, first, you can index into this table using these numbers here to the left, the first column, 1 to 12. So that means you don't have to reference anything except in the table you can reference 7 to talk about this reference. So what has he done to elicit a compare and contrast of all these different research papers? Well, a research relevance table uses columns to differentiate different issues that we're going to associate and compare. The second column, as you can see, is chronological and it tabulates the papers in date order. The second one tells you if they're a global algorithm and what type, genetic algorithm or Bayes or other types. And then it says if they use a local algorithm as well. And these are looking at, remember, hybrid algorithms, so they can use 1, 2, well actually always at least 2 or more. And then it looks at the categories of these and the optimization and the validation and application. So a very good research relevance diagram, a way of depicting the information you've extracted from your past research. Now this is one that one of my students in his degree put together. This is a presentation, and he was very kind and referenced me for giving him the theory behind it, but I think the way he's depicted this is very good. So let's again explain the relevance of a research relevance table. Again, you can index through these numbers in the first column. And then he's got the references, and then he has a number of sub areas, and there's 4 sub areas which they cover. And then he's got, importantly, coloration of the relevance of the topics. So this one, 3, is the highest relevance in this, and so is this one in this area here. And out of these, this one has the highest relevance. So we can see that one of the important things that we'll actually see in another video, which I'll show you on an Excel spreadsheet that builds these tables, and Excel is used because it can build the data structures and then you can depict them in a visualization tool like MS Word, Visio, or any tool you like to draw up these tables. So again, what's he explaining here? Well, first he says the project involves algorithmics of shortest path, and he explains that he's looked at some papers and related these to the relevance for this issue. Then he looks at mobile devices and design of those, because he's going to put his project onto a mobile device, and he says which one of these is most relevant. Then he also looks at software patterns, because he's realized if you're going to get a higher honours degree, you have to show that you know a lot about software engineering, you know about computer science, and one of the sub-issues in that is patterns and design patterns. And then he talks about Dijkstra's algorithm and a paper relating to it and a comparison of the code for that. So this is a very good research relevance table. Now I'm going to cover the issue of parameters. It's not quite in line with this talk, but it's a very big issue if you're developing mathematical models. Now, not enough papers, and you and I, well, I definitely have read thousands of papers that have not delineated, have not depicted, have not stated the parameters used in the model and not differentiated the different types of models in the overall, if you like, set of mathematical models. So why is this a good tabulation of parameters? Well, first, it tells you what the algorithms are used. So it's a cluster of research models and mathematical model parameters. The first set is for an evolutionary computing mathematical model, and these are the names, the parameters of the parameters. One thing that it hasn't got, that I have to say should be more prevalent maybe, is more symbolic. So maybe there should be a table, an extra column with just the symbolic notation of these, and maybe the units as well. So it's a very good table, but we could enlarge on it and clean it up and make it more exact, explicit. So again, we've got one column with the type of algorithmics, one column with the parameter name. We should have another column with the symbols, another column with the interval that they cover, and maybe a description. And this does it all here. But it is a very good parameters table. Now let's look at these diagrams. I first came across these diagrams some time ago, and one of my students did use this methodology to explain the research. So this diagram, I'm still not quite sure what to call it. Maybe it's a research relevant sequential diagram, or research relevant domain algorithmics and data structures diagram. But as you can see, the important thing about this diagram is that it categorizes the type of information that you're using here, data, the technology, the biology maybe, and maybe the algorithmics. Maybe the algorithmics could be depicted a bit better because it's just got one really. The data is, as you can see, categorized into 4 different types. Technologies are also categorized. So that research relevance flow, or, well, we'll have to think of a good name for that. Now here's one of these put to good use. It was my PhD student Don who put this into practice. So here he's got the domains of artificial neural networks, case-based reasoning, and data structures, all linked to a, well, it shows here one algorithm. There'll probably be a set of algorithms, and then you can see the flow of the data, which is nice. So this interactive model, I think, is something like a sequence diagram in UML, something like, but maybe it needs an exact naming. Now I'm going to go off the subject again, and I'm going to do that by talking about algorithmics. This is because not enough papers depict algorithms, because the important thing about a mathematical model which you might be building in your research is how did you process the data, and the structure of the data, and the parameters that you use with those two. In this case, we're looking at the algorithmics. 2 different diagrams. The second one's the more competent one, the more easily explained, because we can index into the algorithm with numbers, line numbers. And if you're not used to this type of diagram, one of the most important things to realize about these diagrams is the symbolic notation here, P open brackets T close brackets, is a data structure. So let's just quickly explain how these algorithmics, not pseudocode, and I must state this, if you're developing in the research community or developing software artifacts in your final degree project, do not talk about pseudocode. We talk about algorithmics. This is high-level algorithmics that can be mapped to any program language. It can be mapped to F#, C#, Python, or it can be mapped to VEE or LabVIEW. The important thing is that this type of algorithmics is something we could put in a patent or a journal or a paper or a thesis. So why is it important then? Well, let's go back to the basics. This arrow says we're doing a transform. This word here, select or recombination and mutate, is the function we're performing on this data structure. So remember, an algorithm processes data structures. How does it mutate them? How does it change them? Well, it undertakes this process, select on the data structure P open brackets, T close brackets, and then once the function has been performed, the new data structure Q subscript S open brackets T close brackets is the process data that has been, if you like, output from this function or piped through it, and this is the translated data type. Now we take this Q subscript S over to here, we then perform the function recombine on it, and we get a new data type. So now you're suddenly seeing, if you weren't used to algorithmics, so all you do is first you initialize the initial data structure, and then you might evaluate to find out, in this case it's fitness functions across the pool, and then you go through a set of transforms, each time re-evaluating the data structure and renaming it. And that's what these algorithms show you here as well, in a bit more complexity. So that's enough of that, and a bit more about algorithmics there. Again, if you're not used to publishing papers or journals, maybe a good idea for you to get used to the naming convention of nomenclature, to say what exactly all your functional mathematics and symbols mean. And that's an example from one of my papers. Now we're going to get down to the basics of why we've looked at all those diagrams. Well, if you haven't understood this, that those diagrams are a way of depicting, delineating and describing the different types of research subdomains that the area you're investigating is involved in. So the important thing here then is that how would you build a bibliography? Now I must explain, make it explicit. A bibliography in our genre is different to a reference list. Why? We could have in a document both. We could have a reference list and then after it a bibliography. How can we do that? Aren't they the same? Well, I'll explain in this case why you could do that. The first thing you will do, and these tables in front of you will show you how to do it in a minute, you will build a bibliographic list. None of those items in that list are referenced. As soon as you cite, put a reference in a paper or a journal or your thesis, they become citations or references, and they move from the bibliographic list to the reference list. So we're talking here about building bibliographies. All the things you've read, all the things you've looked at, scanned, maybe not cited yet. Now, why is this an important thing to do? Well, what you don't want to do is pick up a paper again. So that was an important paper. I'll remember that when I write up. Where was it? What was the important bit? Where was that bit of information? Was it? What type of information was it? Well, this has developed over the years. Hopefully many of my students have, with me and through their great enthusiasm to develop processes like develop this. This is quite well developed now. One of the issues that was added to it some time ago was this issue of colorizing. So these are positive things that can be said about the paper or journal or book, and these are negative things. Oops, a daisy. So what are we looking at here? Well, we're looking at a way to read a document and then start saying, oh, it had an important thing about notation I should note down. It had some very good citations or some quotations that I should note. Or it's abstract. I thought, oh, I like the way they talked about that. And the keywords they've started to use are starting to be a norm, so I should note them down. And also there was some useful knowledge when I read it. Definitions were also good. Maybe some facts or mathematics or algorithmics are important for my research, and maybe the insight gained from the conclusion should be noted, and they're all in a positive context. Now, if anything wasn't explained well enough, or notation wasn't clear, or some citations were missing, or any of these issues which maybe gave you a positive, or actually an inverse positive, a negative view of the paper, you should write them down as well. Now let's put this to practice. So this is two examples, the same table, to write down information when you're reading information from books, papers and journals. So let's look at some examples. Here's an example. When I read this, I thought this is quite important, and it talked about Monte Carlo simulation, and here's some information I compiled about it from this paper. So that's relatively important in the issue of useful information. Let's look at another paper. This one had some notation that I thought was important, so I also made a note of that. This one's got a citation quote. And again, the important thing here is when you're going to reference this quote, it's nearly correct if you place it in a document, except here you need to put a reference, and then it's not plagiarism. So let's move on and look at some other papers. This one is this has got primary and secondary sources. So the primary source is this source, the secondary sources are this. You don't normally quote the secondary sources unless you've read them. But in this, the overview of information was obviously something that was thought to be important, so it's been added with the citations to the secondary sources as well. Again, some useful information here. Now we're going to start seeing some important things that you can see with these tables. The first thing you can see is if the paper is important, because, is that one important? That one's relatively important. That one's moderately so. Moderate. That one is. Now what have I just been saying? What I've just been saying is the amount of information you store in these tables tell you how relevant they are. If you think they're very relevant, you'll probably make a large amount of notes in the different sub categories. Now let's look at another issue that these tabulation methods for the bibliography help you undertake. So that is, if you're writing a journal or a paper for the IEEE, they use numeric references. Therefore, unless you yourself put in the date somewhere, which you might remove later in the journal, you might lose that information. So here we're starting to see, well, I might use this information here, which I've written up here, and prepare a paragraph or two on these issues. But the important thing is, let's have a look at some of these. And we can see, oh, there's a different date. Let's follow on, that's an earlier date, but I've seen that there's a number of papers in this year that are important, so I've started putting the month as well. Now you can start seeing the whole idea of this blue date. The idea is that with this bibliographic tabulation method in MS Word, you could actually start typing up your own, hopefully your own notes on the paper, and then when you come to prepare an introduction or a state of the art, you can cut and paste these in chronicle order into them to start a rough draft, but only a rough draft, remember. And the important thing here is now you can put them in chronicle order because you've got the blue dates that you might in the end remove, but you've got them embodied in the text. So here we are now ready to see that this methodology of tabulating facts from relevant information is very important. The important thing to understand is that you can tabulate, this one wasn't even important at all. So maybe tabulate information, sorry, let's finish this. So one of the important things is the amount of information in each of these tables tell you how important this paper was to the research ongoing in this domain. This one wasn't because there's nothing put down at all. So I think we've now got the idea of how these tables work. The tables work by not just reading the paper. You read the paper or book and you extract information. You extract information in certain areas. Those areas will help you in later time build up research work or research information that will help you write up that research. So thank you for listening to this, one of the first research relevance mentoring videos. This one, as I've said, really highlights the issue of research relevance diagrams, research relevance tables, trees, hierarchies. Thank you for listening.